Cool, sorry about that guys, my tablet ran out of space mid-video. Yeah, but anyway, okay, cool. So here's the question that we have been asked. Okay, so they tell us that our triangles A, B, and F, so triangle ABF is similar to triangle DEB, triangle DBE. Okay, cool. Just remember this is your sign for similarity. Okay, 3 lines going up. Okay, cool. So what we know, they've told us this. Okay, so we don't have to prove that it's similar. They've told us that. Okay, so what we need to find, they've asking us to find the length of BF, and they're asking us to find the length of ED. Okay, cool. So what do we know about similar triangles? First, we know that the angles have to all be the same. But for now, what we need to know is that our sides are in proportion. Okay, so we have to see our corresponding sides, right? So we have to know our order that our things are in. So we look once again between our two angles. So there we've got between beta and between alpha, we've got a 10. All right, so we look for beta and we look for alpha, and there we have a 30. Okay, cool. Now we need to find our other two sides. Okay, so between beta and theta, we have 5. Okay, so we find beta and theta. All right, so we don't know the value there. All right, cool beans. And then lastly, it's obviously the last one between alpha and theta. We don't know that value, but this value we do know. Okay, so for the sides have to be in proportion, right? Because they told us that it's similar. So we need to find what that proportion is. All right, so if we're going from this triangle to that triangle, right, we are getting bigger. So we have to be timesing by some value, right? We have to be timesing by whatever value we find. Okay, that's just C for constant. All right, how we find that? We look at the ones that we have information on both triangles. So for this one, the blue one here and that one, we have both of those sides. So we're going to put the bigger one over the smaller one, 30 over 10, right? So we're going DB over AB. Okay, and that gives me 3. So in other words, what I did is that I timesed my 10 by 3 to get to 30. All right, so what we now know, which is awesome, is if we times our 5, if we go 5 times 3, we should get this value here, because that's my corresponding pair. All right, let's just write down my corresponding pairs for you guys. So we know that AB is corresponding with DB, right? We know that AF is corresponding with ED, and we know that BF is corresponding with EB. Okay, so those all need to be in proportion. Okay, I'm not even going to attempt to spell that right now. Okay, so now we've figured out how much we timesing by. So like I said, we're timesing by 3, right? So if AF is in proportion to ED, we know that we have to times 5 by 3 to get to ED. So in other words, ED is 15. So we go ED is equal to 5 times AF, which is then, 3 times AF, 3 times AF, and AF is 5. So we get 15. Okay, cool. So now we have that one and this one. So we just need to find our BF. So we need to go from our big triangle to our smaller triangle. So we're getting smaller, right? So when we get smaller, we divide by our 3. We divide by our proportion value. Okay. So what we have then is we find our corresponding pair. So we're going from EB to DF. So we've got EB is equal to So EB, we're going to divide that one by 3. So let's do it a different way rather. Let's say that DF, because that's what we're trying to find, is equal to EB, and we're going to divide that by 3. Okay, so EB in this case is 21. We divide that by 3, so I get DF is equal to 7. Okay, cool beans. So that's just a bit of use of some probability. Okay, I also want to show you some useful tools that come up quite often. So some useful tools in doing similarity. Okay, firstly is interior angles of a triangle. Okay, so don't forget the rest of the stuff that you know about triangles. Okay, so let's say, so A is interior angles of a triangle. Okay, cool. So let's say that's 50, let's say that's 60, and let's say this one is 70 and this one is 50. And I ask you to prove that these two are congruent, similar to each other. So we've got A, B, C, D, E, F. Okay, so we need to find, remember, to prove that something is similar, we need to prove that all 3 angles are the same and the sides in proportion. So just for this one now, we're going to leave out the sides in proportion because we've already done it, and just focus on using interior angles of a triangle. So to find, we need to find C and we need to find F. Okay, to see if they're the same, because that's what we need to find, right? So we use interior angles of a triangle. So in triangle ABC, we know that angle A plus angle B plus angle C must give me 180 degrees, right? Interior angles of a triangle. So we know that 50 degrees plus 60 degrees plus C must equal 180. So we get angle C is equal to 180 minus 50 minus 60, and C gives me 70 degrees. So let's fill that in. 70 degrees. Okay, cool, which is looking good because there's a 70 over there. So we've got our 50 here and we've got our 50 here. So if this last value, angle F over here, if that is equal to 60, then we're good. So let's hope that it is, right? So we go in triangle DEF, we have angle E plus angle D plus angle F is equal to 180 degrees, and we're going to do the same thing. So we got 70 plus 50 plus angle F should give me 180. I'm going to bring those over, so I'm just solving for my F, right? Minus 70 and minus 50. So my F should give me 60 degrees. So that there is 60. Okay. So that's one way of getting all the angles are the same. So I've seen this often in tests. They like to do it. That's why I'm mentioning it now. Okay. And the other thing that I see often is when they give you a big triangle, and then inside that triangle, they put another triangle. So they do something like this. And they ask you to prove that they are similar. So it's obviously not congruent because the one's inside the other one, right? So they can't be the same side. So let's call this alpha, this angle alpha. Let's call this angle beta, and this angle theta, and this angle x. Or actually, let's just do that. Getting ahead of myself here. So we're going to call that D1 and that E1, and this is E2 if we need it, and E2 if we need it. Okay, so if they ask us to prove that triangle ABC is similar to triangle ADE. Okay, so what we have straight away, okay, is that angle A is common. All right, it's the tip of both of those triangles, so you can write that in. Okay, so we go angle A is equal to angle A, the reason being common. Okay, cool beans. But now we're a little bit stuck. So a powerful tool that we must be able to use is that these two lines are parallel. Okay? And then those lines, they run on those two angles here. So angle B and angle D1 are the same. Okay? Corresponding angles. Right? Remember your F shape of your fun angles, right? Corresponding angles. All right, and the same can be said for this side. We have another F shape over here. So that one is equal to that one. So we can then say that angle beta must be equal to D1 because we have corresponding angles and DE is parallel to BC. And we do the same with angle C, so we say theta is equal to E1, angle E1, corresponding angles, DE, so that's a B, DE is parallel with BC. So now I've got all my angles, right? So I have a equi-angled triangles. Okay, which is what we need, and then we can work out the similar sides now. Okay, so let's say this was this length would be 3, this length would be 9, this length is 10, this length would be 30, this length was, let's say, 15, and that length would be 5. So you can work out the proportionality. So that one will be proportion to this one is in proportion to that one, and lastly that one is in proportion to that one. Okay, cool. I just want to clear something up here. I use these symbols just for illustration's sake. Normally when you do a straight line, it means that they are equal to each other. So I'm just showing you now that these are proportionate, just using them as a way of explaining. So they're not normally like that, but they don't normally use those symbols for similarity. That normally mean that they're equal to each other. Okay, correct. So those are the tools that we use. Just remember that you have corresponding angles inside your bigger one, and don't forget your interior angles of a triangle. Okay.